So, continuing with our series of discrete transistor circuits, here's the other end of that blue breadboard that I had earlier. Now the thing is, to be absolutely honest, I'd forgotten what I'd built here. I'm not very good at writing down and noting what I've built. So this one, it turns out, is a logic gate. I've got most of the dust off it now. It has been here a while, so it's time to make a video and then maybe take it apart again, because there's no point keeping these things if I'm not going to be actually using them. So we've got here, running on 6 volts, a logic gate. Now I mentioned earlier on that the Apollo guidance computer used NOR gates. They were 3 input NOR gates, and that means they had 3 transistors per gate, and they were on integrated circuits on little pieces of silicon in packages. The circuit of those NOR gates, very simple: 2 transistors in parallel makes you a 2 input NOR gate, 3 transistors makes you a 3 input NOR gate. This one is a 2 transistor NOR gate. These 2 transistors here are, I put my finger another way round, these 2 here are a NOR gate. Now anyone who knows Boolean logic will have heard of De Morgan's theorem, which says that if you want to make a NOR gate into an AND gate, you need to invert the inputs. So that's what I've done. I've got 2 inverters over here. So these 2 transistors at this end of the breadboard are acting as inverters. So these 2 resistors here are the 2 inputs to this gate through the inverters, and then these sideways resistors here feed the NOR gate, and then the output is an LED driver. The transistor there with the white spot on it. I don't know what happened to that. Someone's put some white paint on that one. They sometimes did that to indicate the gain of the transistor. They put different colour spots on them. That one, out of my junk box somewhere, has a white spot. That's acting as the LED driver, because these logic gates haven't got enough output drive by themselves to drive LEDs, unlike a TTL logic circuit might be able to. So I've just added these 2 wires going to the input resistors, these 2 stiff wires here, and I've added these 2 push button switches so I can operate the thing a bit more easily. Now it's an AND gate. The light will come on only when the 2 inputs are both 1. Now these little red wires are supplying logic 1 to the switches. If I press one of them, nothing happens. If I press the other one, nothing happens. That's because I'm only making one of the inputs to this logic gate high. I need to make both inputs high, so I need to use that one and that one together, and the output lights up. Only one input, nothing happens. Both inputs, you get the output. This is acting as an AND gate, and it shows that for the various resistor values that I've chosen here, the transistors that I've got, they're all NPNs, all in TN92 packages, 6 volt power supply. The choice of resistor values, the choice of transistors, the circuitry is valid. It's doing what we thought it was going to do, which is invert the inputs of a NOR gate and make an AND gate. So that's another simple little discrete transistor circuit that does a very simple logic function without any ICs.